Great. Here we have the first example from the second part of this chapter 13.5. Now in this example we want to calculate this surface integral, and here we have a vector field. So this is my vector field f, which equals to 3x comma 2y comma c. This is your vector field f, and my S is the surface. S is the portion of the plane 2x minus 2y plus c equals to 5 that lies inside the cylinder x squared plus y squared equals 1. Now, so basically we have this cylinder. Okay, let's say you have a cylinder like this. Okay, now let's draw the coordinate axis, y and z. Of course it should be symmetric about the z axis, but we have this cylinder, and then we have the plane. Let's say this is the plane. And if you consider the intersection of the plane and this cylinder, you will get something like this. Let's see, this is your plane. What's the plane? This is the plane. 2x minus 2y plus c equals to 5. Now, usually we express a surface in terms of c, in terms of x and y. So let's solve for c, and c equals to 5 minus 2x plus 2y. Okay, good. Okay, let's calculate this surface integral. Surface integral of 3x comma 2y comma c dot ds over the surface S. This equals to, now what is your surface S? Your surface S is this part. It's your surface S. So we want to consider the surface that lies inside the cylinder. Now what we need is the normal vector to this surface. To calculate the normal vector, we should use this formula. So here we have this normal vector field, normal vector n. Now previously I defined the formula for the surface integral of a vector field, and it is given by this. So this surface integral f dot ds equals to your vector field dot minus partial f of partial x comma minus partial f of partial y comma 1. So I have this double integral over a domain D. Then here we should have the vector field 3x comma 2y comma c dot minus f sub x minus f sub y comma 1 dA. Now remember, we evaluate this line in this surface integral on this surface. So on this surface, your vector field equals to 3x comma 2y comma, the c coordinate is given by this formula. The c coordinate is given, or c coordinate equals to 5 minus 2x plus 2y. Again, on this surface, the c coordinate is given by 5 minus 2x plus 2y. So now your right hand side becomes 3x comma 2y comma 5 minus 2x plus 2y dot, that's a dot product. Okay, let's calculate. So this is your f. Let's calculate f sub x, which equals to negative 2. Partial derivative of f with respect to the x variable equals to negative 2. F sub y equals to positive 2. If you take the derivative of this one with respect to the y variable, you will get positive 2. So now you have, and remember here we have these two extra negative signs. So you have minus 2 comma minus positive 2 comma 1 dA over the domain D. Now your domain D is the projection of this portion on the xy plane, and if you see its projection, you will see a circle with radius 1. So that's the projection of this surface. That's your domain D. Okay. Let's simplify the integrand. So this is positive 2 times 3x should be 6x. Negative 2 times 2y should be negative 4y plus 5 minus 2x plus 2y over the domain D. Your integrand becomes 6x minus 2x should be 4x, minus 4y plus 2y should be negative 2y plus 5 dA. Now if you look from the top, of course you will see the boundary of the cylinder. That's here, domain D. You will see a circle with radius 1. This is x squared plus y squared equals 1. Its radius should be 1. Now it is easy to use the polar coordinate polar coordinate system to solve this integral. Okay. Now in polar coordinate system, x coordinate equals to r cosine theta, y coordinate equals to r sine theta plus 5, and what is dA? dA equals to r dr d theta, and r goes from 0 to 1, theta goes from 0 to 2 pi. So let's distribute this r. Let's distribute this r before we integrate with respect to the r variable. If you distribute this, you will get 4r squared cosine theta minus 2r squared sine theta plus 5r dr d theta. Let's integrate with respect to the r variable first. So cosine theta and sine theta can be treated as constants. So you will get 4 cosine theta times integral of r squared is r cubed over 3 minus 2 sine theta times r cubed over 3 plus 5r squared over 2 and next we want to integrate this result with respect to the theta variable. So before we do that integral, let's apply the lower limit and the upper limit and the lower limit. If you apply the upper limit, you will get 4 over 3 cosine theta. Now, the lower limit will give you 0, so there is no contribution from the lower limit. D theta 0 to 2 pi. Let's do this integral. We have 4/3. Integral of cosine theta should be sine theta. Minus 2/3. Integral of sine theta is negative cosine theta. Plus 5 over 2 times theta, because here we have 5 over 2 times 1, integral of 1 with respect to the theta variable is theta, 0 to 2 pi. Apply the upper limit and then the lower limit. Minus the lower limit, minus 2/3 times negative cosine 2 pi minus, and then we have minus cosine of 0 plus 5 over 2 times 2 pi. Of course, the lower limit will give you 0. Now, sine 2 pi is 0, sine 0 is 0. Cosine 2 pi is 1, so here we have negative 1. Then cosine 0 is 1. 1 times negative times this negative becomes positive 1. And I think the answer should be 5 pi. So this is the way we calculate the surface integral of a vector field.